Now we are going to start with the de Broglie relationship. As I told you that de Broglie and Heisenberg uncertainty principle is actually the major phenomena that gave blow to the Bohr's atomic theory, right? So for now we are in situation that you should know that what actually is the de Broglie or the Heisenberg uncertainty principle that could not be explained by the Bohr orbital theory. Right. So what does de Broglie relationship means? Till now we have learned that light has a dual character. That means it can behave as a particle and as well as it can behave as a wave. In this phenomenon, like in de Broglie and uncertainty principle, what we will be trying to prove that the particles also possess a dual character. That means they behave as wave also, and they are themselves like particle also, and they emit wave also. Right. So what does de Broglie states actually in its relationship? It states that all material particles we are talking about, they when in motion they produce waves. So that means, as we know, they are particles, so they have a particle like character, and when they are moving they are also emitting waves. So that means they have wave like character also, but only when they are in motion. So he derived even the mathematical expression for it. So just look at the board. He said, like, if the particle is if material particle is also possessing a dual character, so that means they will possess the energy also. So let us see that what kind of energy it possesses. So according to Planck's quantum theory, we know that the energy possessed by the particle is something equal to E is equal to h nu, where h is Planck's constant, you know that, nu is frequency and E is energy. So I'll put 1 here. Likewise, we know that if it behave as a wave and the energy possessed by the wave according to the Einstein mass equation, it is E is equal to mc square, where m is mass and c is velocity of light. And when we are considering any other particle like a particle other than photon, we can just replace this c with v. We will do it later on. So from equation 1 and 2, if we compare them, so we get h nu is equal to mc square. We get h nu is equal to mc square. Now as we know that nu is equal to c over lambda, it is a relationship between the frequency, the wavelength and the velocity. That is nu is equal to c over lambda. So by substituting this value here in nu, what we get hc over lambda is equal to mc square, c cancels c, and what do we get? We get lambda is equal to h over mc. This is the expression what we get for the de Broglie relationship, right? But here the c is the speed of the light, like if we consider photon. But if we are considering some other particle, we can just replace this c with v. So we can also write lambda is equal to h over mv. So this is actually the mathematical expression which is derived on the behalf of de Broglie relationship. So what does actually we conclude by this relationship? We conclude that lambda, that is the wavelength produced by the particle when it is in motion. As I told you, like a particle when it is motion, it is emitting waves. So it is emitting waves means it possesses certain wavelength. So that wavelength is inversely proportional to the momentum of the particle. It is inversely proportional to the momentum of the particle, means more is the momentum, less wavelength it is going to produce, less is the momentum, more wavelength it is going to produce. So this is what we derived on the behalf of de Broglie relationship, that is lambda is inversely proportional to 1 over p, or if we talk about mathematical expression, we write lambda is equal to h over mv, where v is the velocity of light. But if we get photon, so in that case we will be replacing v with the c, because we know that c is the speed of light corresponding to 3 into 10 raised to power 8 meter per second. So this is what. Now if we talk about the significance, like what does the de Broglie relationships does it have some important significance in our routine life or not, right? So we will see that. So in daily routine what you see, we are just doing the significance. So in daily routine, what do you get to see? What particles do you get to encounter? Obviously, we get to encounter only macroscopic particles. That means the big size particles. We don't encounter the microscopic. That means the very minute particles which are not even visible with the naked eye. We don't encounter that kind of particles. So that means when we encounter macroscopic particles, as I told you that in daily routine we are encountering macroscopic particles. So that means they will possess mass and their mass will be sufficient high. Right. So as we know, lambda is inversely proportional to momentum, that is m into v. So that means more is the mass, less is the wavelength produced. So that means as we encounter macroscopic particles in our daily routine, so that means their mass is comparatively high, and if we compare, like if we take into account their wavelength, so wavelength produces almost nil. So that means it doesn't serve a significance in our daily routine, because in daily routine we get to encounter only macroscopic particles, and macroscopic particles have a sufficient mass, so they produce wavelength almost of nil type. Right. So that means it doesn't have any, it is not serving any significance in our daily routine. But as far as microscopic particles are concerned, it plays an important role, right? But like if we are talking about the significance in our daily life, so it is not playing any significant role. But if you are talking about the microscopic particles, it is playing a great role because they possess very low mass. Low mass means the wavelength produced will be comparatively very high, which can be taken into use for solving any purpose, right? So this is what we have de Broglie. Now, as we did in Bohr postulate, we did one of the Bohr postulate that only that orbit is permitted in which angular momentum of electron is integral multiple of h over 2 pi. We did this postulate in Bohr theory that only those orbits are permitted in which the angular momentum of electron is equal to integral multiple of h over 2 pi. Right. So we will be we are able to derive this postulate of Bohr by using the de Broglie relationship. So just listen to me how. So now, according to de Broglie, that according to Bohr, if we talk about electrons are present, you can say this thing, we have a nucleus, and in extra nuclear part electrons are present. So are they stationary? No, they are moving, right? They are moving. So if they are moving, so that means according to de Broglie that they should produce wave. They should produce wave. So this can happen that the ends of the wave meet each other, or end of the waves do not meet each other. So anything can happen, right? If the two waves, like you can say when the two waves meet with each other, they are said to be in phase. So this is my wave which is in phase, and this is my wave which is out of phase, because the ends are not, you can say they are not meeting at one point. So as we know that the electrons are present in a definite orbit, so obviously if they are emitting a wave, so that means only that orbit is permitted in which the wave of the electron lie in phase. Obviously only those orbit will be permitted in which the motion of the electron or the waves produced are in phase, right? So for the wave to be in phase, there has to be a certain condition that has to be satisfied. Like again, for the electron wave to be in phase, there is a condition that has to be satisfied. And look at the board, what is that? So for the wave to be in phase, the circumference should be integral multiple of wavelength. Circumference should be integral multiple of wavelength. If it is like that, then only the wave is going to be in phase, and if we know that only that orbit is permitted in which the wave is in phase. So we can just put the de Broglie relationship here. We know lambda is equal to h over mv, so I am putting that. By just shuffling them, what do we get? We get mvr, I have just brought this here, is equal to integral multiple of nh over 2 pi. So this actually proves the postulate of Bohr model, that only that orbit is permitted, not orbital, right? Only that orbit is permitted in which the angular momentum of electron is nothing but integral multiple of h over 2 pi. So this is what we have the de Broglie relationship. So this is one of the serious, it is actually a phenomena which gave a serious blow to the Bohr theory, because he wasn't able to explain this, because according to him electron is just a particle, and de Broglie just revealed that the electron has a dual character. That means it is a particle anyway, but when it is in motion it is producing a wave. Now we will just start with the another phenomena that the Bohr failed to explain, that is the Heisenberg uncertainty principle.